Hello, class. So today we're going to be looking at some ethical concerns regarding data visualization. So the first concern is using a misleading visual scale. So one way data visualizations can be manipulated or misleading is by changing the scale of your axes to make small increases look more dramatic and more drastic than they actually are. So in this example, let's suppose that we have a company that wants to show their revenue to stakeholders, and on average, they're making an extra $200 in revenue a month. On the first graph, we're going to start the y-axis from 11,000, which is their baseline, and then the next one, we're going to start it from 0 to show the difference between how you can make the graph appear drastic versus what the actual change in revenue is. So as you can see here, we take these months, January to May, and then we increase the revenue by 200 each month, and then we're going to plot them side by side. On this first one, though, we're going to set the Y limits at 10,900, so it's just below 11,000, and then the other one we're going to set it at 11,900, so it's just above the top. And the other one, we're going to start it from 0 to give the whole picture of the Y-axis. So as you can see here, these numbers are the same, but on the left, it's making it look like they're greatly increasing their revenue per month, whereas on the right, you can tell that their change in revenue is actually not that drastic. Another way that you could manipulate data visualization is by biased or cherry-picked samples, and this is when you take samples of data that aren't representative of the population. So, for example, I said let's look at a group of employee scores and then say that we want to show the distribution of employee score ratings within a company to stakeholders to show that our productivity is high. One way that a company could manipulate this is by only selecting the high scoring employees versus all the employees as a whole population. So here we're going to simulate a high score employees where we're going to select random ins from 4 to 6, but then for all employees, we're going to select the same size, but have it from 1 to 6, and then plot them side by side again. And as you can see here in this histogram, we can see that all the employee ratings are falling between 4 and 5, so it looks like we're doing great. But then when we look at the actual score of the employee ratings, we can see that the distribution is much wider than that. Anyways, thank you for watching, and this has been misleading representations of data.